this video, we will look at the quotient rule. Suppose y is equal to x squared. Then we know that the derivative will be 2x. Suppose y is equal to sine x. Well, then we know that the derivative will be cos x. Now suppose y is equal to x squared over sine x. What is the derivative of this function? We may think that the derivative would just be derivative of x squared over the derivative of sine x. This is not the case. Let us look at an example. If y is equal to x, then we know that the derivative of y is 1. But I could have written y as x squared over x, which is also x. Applying my logic, the derivative of this would be 2x over 1. But this is not correct because the derivative of y should be 1. So, the derivative of a quotient is not the quotient of the derivative of each term. Do I always need a rule though? For example, if y is equal to x squared minus 4 over x minus 2, I don't need any special rule here to find the derivative. I can factorize the top into x plus 2 times x minus 2. And since there's an x minus 2 in the denominator, I can cancel above and below, be left with x plus 2, and then find the derivative, which will be 1. Let's find a rule to help us to calculate the derivative of a quotient. Suppose y is equal to fx over gx. We know that the derivative of y would be the function evaluated at x plus h minus the function evaluated at x all over h, and then we take the limit h going to 0. On the top, I am subtracting two fractions, and I should combine this into one fraction. So now I have fx plus h times gx minus fx times gx plus h over gx times gx plus h all over h. I shall add and subtract a term on the very top to help me simplify. In red you see I have minus fxgx plus fxgx. These terms cancel, and so the net result is no change. However, as you can see in green, I have gx in common in the first two terms and fx in common in the last two terms. Factoring this out, I'll be left with gx times fx plus h minus fx, then minus fx times gx plus h minus gx over gx times gx plus h all over h. I shall multiply the top and bottom by 1 over h. The h on the bottom is gone, and now there's a h only on the top. And the h enters the equation by multiplying gx times gx plus h. What I'll do next is split the top into two fractions with h as the denominator on both. This is still the same thing, since I can reunite these two fractions to write them all over h, which is what I had. Now, notice if I apply the limit to each term, I have, firstly, the definition of what the derivative of f is, and secondly, the definition of what the derivative of g is. Applying h to 0, and I'll be left with gx f derivative x minus fx g derivative x all over gx squared. Or equivalently, the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Let's look at an example using this rule. What is the derivative of x squared over ex? Well, x squared over ex is of the form a function over a function. And the rule for the derivative here is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. bottom, ex, times the derivative of the top, which would be 2x, minus the top, x squared, times the derivative of the bottom. Derivative of ex is ex, all over the bottom squared, which is e power 2x. What is the derivative of sine x times ex all over x? I don't need to simplify this. We just want practice using the rule. Well, this is of the form a function over a function. And applying the rule again, bottom times the derivative of the top minus top times the derivative of the bottom all over the bottom squared. The bottom, x, times the derivative of sine x ex, and I will need to use the product rule here, minus the top, sine x ex, times the derivative of the bottom, derivative of x is 1, all over the bottom squared, which is x squared. Now I need to use the product rule to find the derivative of sine x ex. So, derivative of sine x is cos x, then I keep the ex the same, plus keeping the sine x the same, and doing the derivative of ex, which is ex. Now I keep the rest of the numerator the same, sine x ex, followed by the 1, all over x squared. Here's an example I want you to try. What is the derivative of sine x over x? And you do not need to simplify. Pause the video, try, and resume when you're ready to see the answer. Y equals sine x over x is of the form a function over a function, and the derivative would be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So in this case, the bottom, x, times the derivative of the top, which is sine x, and that will become cos x, minus the top, sine x, times the derivative of the bottom, derivative of x is 1, all over the bottom squared, which would be all over x squared. That's it for the quotient rule.